All right, we're going to use proportional reasoning here to talk about the consumer price index and inflation. So inflation is basically the rise in the general level of prices of goods and services in the economy, right? And I say rise because they tend to go up, but they could go down. The consumer price index, then, that's what all this number is. It's really small to see, I understand, but that's the consumer price index, and that's the number that reflects the changes. So it shows the rise of goods and services. So when you're looking at this, number one, what does the trend in the values tell you? Well, if you start down here in 1976, where it was 56.9, and then you look, and these are annuals, and you go all the way to the top, 2015, where it's 237, you can see that the general trend is an increase. And what does that mean for you? It means everything that you buy is more expensive. And depending on how old you are, if you think back, I remember when gas was 92 cents a gallon. Now, that's not bad because gas isn't super expensive right now. But I also remember when eggs were like 48 cents a dozen instead of like 2 something that I'm paying now, right? So prices of goods and services are going up. Now, for 1998, this is just so that you know how to use the table. This is the number that goes with 1998, and it's 163.000. Now, with the CPI, we generally use 1983, which is right here, as a reference. 99.6 in 1983 is about 100. So for this basket of goods and services in 1983, it was about $100. That same basket of goods, so we're talking like milk, eggs, just general stuff, they check the same thing every month so that it's consistent. In 1998, it would have cost you $163. So $63 more in a 15-year span. So that's what we're talking about. So we're going to use this table to kind of help us through the problems in this section. So number 3, by what year had the values of goods and services doubled from their 1983 value? Remember, in 1983, they were about 100. So we're going to look for about 200. So if you go back and you're looking at these values here, where does it hit 200? Well, it's pretty close about right here, 201.6. So 2006 is about where it doubled. Number 4, inflation can be quantified by the change in the CPI from a year earlier. So what's the change from 2014 to 2015? Well, if you go back, in 2015, the CPI is 237.017, and in 2014, it's 236.736. So that is a difference of 0.281. Now, what does that mean? Well, that means from 2014 to 2015, this basket of goods and services rose by approximately 28 cents. Because, again, money is 2 decimal places. So we had an increase of approximately 28 cents from 2014 to 2015. In 2015, how much more would your basket cost than it did in 1983? Well, remember that in 2015, we're at approximately 237, and I approximated. And in 1983, we were at approximately 100. So how much more? Well, about $137 more. So more than double. We're talking, 32 years. The price of that basket of goods is more than doubled, which is really just crazy to think about. Okay, now, how can we use this? Okay, so if we think about, if things, this case we're talking about a McDonald's hamburger, if things, the prices of things, if they rise with inflation, so at the same rate, then we can use the CPI to predict cost, right? So in 1979, we have a McDonald's hamburger cost 38 cents. What does that equate to in 2015 dollars? Okay, so I always do like the years, 1979, and we're comparing to 2015. And we're talking about proportions. On the top, I always put money, and on the bottom, I always put CPI. So I'm consistent. I have my years, I have my money, I have my CPI. So in 1979, this hamburger cost 38 cents. Well, in 1979, the CPI is 72.6. And I got that from here, 1979, 72.6. So you pull it from that table. And then we're comparing it, to 2015, which is the 237. So I would put 237.017 down here. and I'm trying to find what it is in 2015. So I cross multiply to solve. So 72.6x equals 90.06646. I divide both sides by 72.6. And in 2015, that hamburger should cost $1.24. And how does that compare? I have no idea. I don't buy hamburgers at McDonald's. I don't know. So, but I think it's a dollar menu, right? So it's probably pretty consistent. All right. According to College Confidential, the starting annual salary for a college graduate in 1983 was $25,000. How would that compare, right, in 2013? So we're looking at 1983 to 2013. I'm going to put money on the top and CPI on the bottom. So in 1983, the value is $25,000. The CPI in 1983 is 99.6, pulling it from that table. In 2013, the CPI is 232.957. What would the price be? So you cross multiply, divide, and you should get a value of approximately $58,473.14. Right? When you cross multiply and divide. Now, in the second part of this, it says, what about in 1976? Well, you should still use your 1983 as your comparison because they give you the $25,000 for the 1983. And you're comparing that to 1976, which we know has a CPI of 56.9, right? It's less. So the salary should be less than $25,000. And when you cross multiply and then divide, you will get a comparable salary of $14,282.13. When you think about that now, it's like, man, $14,000 would be, a slap in the face. But at the same time, back then, that was a lot of money. So it's just, times have changed. All right, let's do another one. And you might want to try one of these on your own and then come back and check it out. But at number 3, suppose a soda cost 25 cents in 1977. How is that comparable in 2015? Okay, so my years, 1977 compared to 2015. Money on top, CPI on the bottom. So we've got 25 cents compared to my CPI in 1977, which is 60.6. I'm not sure on the cost in 2015, but I know the CPI is 237.017. Cross multiply and divide, and that soda should cost 98 cents. Now, how does that compare to the actual cost? Well, this is an interesting thing. You go to a gas station, if you're buying a 20-ounce bottle, you can pay, $1.69, $1.79. Maybe you get them 2 for $2.22 or something. But this is an approximate for a 20-ounce bottle. Now, you can buy a can of soda in some, Walmart in the vending machine for 50 cents. So there's a lot to talk about. But if we use this value that I just threw out, when you use the CPI, this is what it should be. This is what it actually is. So because the actual is higher than what it should be, soda has grown faster than inflation. And that makes sense. If it's equal to inflation, it would be 98 cents. Faster than inflation means it's higher than what it should be. All right, let's do some work here. Federal debt, we're going to throw that in here with our CPI. But in 2000, the federal debt was $5 trillion and some change, with a population of 281 million. Let's find the federal debt per capita. Now, I'm going to do this an easy way, and I'm going to say 6 zeros means times 10 to the 6th. So I can write my federal debt as 5,674,178 times 10 to the 6th. And then I have a population of 281 million. Million means times 10 to the 6th. And you might say, oh, I see why you did that. Because now my times 10 to the 6th cancels out. And I can just divide these two numbers. And I end up with a federal debt per capita of $20,192.80. So that's federal debt per capita. So in 2000, if everybody would have paid a little over $20,000, we could have paid off the federal debt. Now, in the part 2, it says use the CPI table to say, let's pretend that this grows with inflation. So in the year 2000, we had a federal debt per capita of $20,192.80, and the CPI for 2000 was 172.2. Then in 2010, we don't know what this the federal debt per capita, but we know that the CPI is 218.056. So to find that value, we do our cross multiply and divide, and we end up with inflation. The federal debt per capita in 2010 should be $25,570.04. Now, we're going to move on to the next problem and see, did that actually happen? Okay, so we see that in 2010, the federal debt grew and the population grew. So again, I'm going to take these 6 off and do times 10 to the 6th. And then I have my 309 million, which is times 10 to the 6th. So that they cancel out, I just divide these numbers. And in 2010, the federal debt per capita rose to $43,888.75. Now, if you recall, it should have been 25,000, right? Because it says compare. So this is what it should have been. This is what it was. Therefore, because it's greater, the federal debt per capita grew faster than inflation. That's what it means. Okay? All right, just a few more problems. We're going to do kind of a minimum wage problem. So we're given the minimum wages for all these different years. Now, let's find the ratio of current minimum wage. And when I say current, I'm going to use 2013 because that's the most current on this table. So current to 1980. So current to 1980 is $2. And what does this mean? Well, if I divide these two, so that's what I'm going to do. I'm going to divide. I get 3.625. So when I interpret this meaning, I can say that minimum wage is 3.625 times what it was in 1980. That's what that means. Okay, when I divide and I have that value, that's what it means. Okay, so now we're going to play, and we're going to use this, oops, wrong button. We're going to use this table here, and our CPI table, to determine whether minimum wage has kept up with inflation. Okay, so we know what it actually is. What should it have been? If we compare 1980, and again, we're going to use 2013 because that's, I don't know anything about what it is currently. Money to CPI. Well, we know in 1980 it was $2. We're trying to figure out what it should have been, right? We know what it really is. What should it have been in order to keep up with inflation? So in 1980, we have a CPI value of 82.4, and in 2013, we have a CPI of 232.957. So when I cross multiply and I divide, I end up with a minimum wage of $5.65. This is what minimum wage should have been in 2013 if it kept up with inflation. Well, if you recall, the actual is $7.25. So because the actual is higher than what it should have been, we can say that minimum wage has grown faster than inflation.